Hi Advanced Maths, I'm going to be doing today the proof for the negative reciprocal in parallel lines. Okay, so negative reciprocal in, sorry, not parallel lines, perpendicular lines. Parallel lines have the same gradient, but in perpendicular lines the gradients are negative reciprocals. Okay, negative reciprocal in perpendicular lines, so therefore m1 times m2 should equal minus 1 in perpendicular lines. That's what we're trying to prove today. Okay, so what I'm going to do is I'm going to draw two lines on my Cartesian plane. Here's my lovely Cartesian plane, and we've got our first line here, line 1. Okay, and here's our second line here, line 2. And this is going to be m2, this is going to be m1 for their gradients. Alright, now what we know about these lines, and I'm just going to label some things here, that this is going to be A, B, and this over here is going to be C, and I've got a little line in the middle which is going to be X, and over here this little section is going to be Y, and this little section over here is going to be Z. Okay, and down here theta. Now we know that the gradient, that's m1, not m2. The gradient of line 1, m1, is going to be rise over run. It rises x and it runs y. Okay, the gradient of line 2 is going to be minus x and it's run z. Okay, so that's very interesting. Now what we also know is that tan theta equals x on y, opposite over adjacent. No. Yes, opposite over adjacent. Okay, tan theta equals x on y. And we also know that tan theta equals opposite over adjacent, a over b. Okay? So x on y is going to equal a on b. That's just something interesting to note. Over here, m2 is... we also know that this here is going to be 90 minus theta. If that's going to be 90, angle sum of the triangle is going to be 180. So this is going to be 90 minus theta. Now tan 90 minus theta, I did a double theta there, that's okay. 90 minus theta is going to be x on z. If that makes sense. Okay, so that means that minus tan 90 minus theta equals minus x on z. So that means that minus tan 90 minus theta equals m2, okay? Because I'm equating this here is exactly the same as that. So we know that m2 is going to be minus 90 minus theta. Also, tan 90 minus theta is b over a. So minus b over a equals m2 by this second triangle here. Okay, so if we do m1, which is also equal to a over b, and m2, which is also equal to minus b over a, we can see that they're the negative reciprocal. So let's go a over b times minus b over a. Yes, of course, that equals negative 1. So you can see if this is a right angle, that the gradients are going to be negative reciprocals and therefore multiply together to equal negative 1. That's the proof. Proof is in the pudding, people. Thanks, Advanced Maths.